Thanks, Alan. And I'm going to blow through this pretty quickly. I'm from the Chicago office. Alan mentioned he's from the the Cleveland office. Joe's from our Columbus office. We've got Megan, who is from our Indianapolis office. He's not going to be speaking today, but we've got Dean Leffelman, who's from our office right down the road in Lisle here in DuPage. I'm a litigator, so I'm the guy who you don't want to have to see, because A, it's not a whole lot of fun having to sue somebody, but B, it's even worse when you're the one getting sued. So we're going to talk about some of the unique issues that face 3D printing manufacturers that you might not otherwise face as kind of a subtractive manufacturer, where you're shaving off metal or plastic or doing something like that. Essentially, we are really kind of in a brave new world when it comes to litigation and insurance issues, because this is a relatively new technology. 3D printing has actually been around since the 1980s, but it's really just been in the last decade or half decade that it's really taken off. When it comes to litigation, the main kinds of litigation that we're going to be talking about are, first, intellectual property claims, as Alan kind of talked about, and I'm not really going to focus on that because those are somewhat similar to what you're facing already. The biggest thing where there might be a differential between the kind of manufacturing you're doing now versus additive manufacturing or 3D printing is product liability claims. And then finally, there are, of course, breach of contract and breach of warranty claims, which, again, are not all that different from what you would face now as a typical manufacturer. Now, when it comes to 3D printing, the uses, we've talked about the fact that it's not just prototypes anymore. As Kelly mentioned, prototyping is is something that 3D printing is extremely well suited for, because you can make something faster and cheaper, and you can see if it works. And if it doesn't, you can prototype another one. But it's not just for prototypes anymore. Now companies are making difficult to make high-end products. 3D printing at this point is too expensive and too time-consuming to make 15,000 air vents or 15,000 little pieces for a car, presumably. That might be changing, but really where we're seeing it is some of these difficult-to-make high-end products or prototyping. I was talking to George at my table, who is in the control system business. They make control systems for HVAC systems and so forth. And if you are making a prototype of a new system, this might be something that it's well suited for. Now, if it's the final product that you're manufacturing, maybe not, at least not yet. Now, we see this, first of all, we see it in aviation, in the automotive industry, we see it in life sciences. In aviation, for example, here's the new Boeing 787 LEAP engine. And I'm not sure if you can see, but just to give you a sense of how big that is, you can see the guy standing next to it in the middle. It's a big engine. Well, one of the things that GE, who is the manufacturer of this engine for Boeing, is making now is jet fuel nozzles. There are 19 of these all the way around inside each of the engines on this two-engine Boeing 787. Now, previously, and this is a very sophisticated piece of machinery. This nozzle, basically what it does, it shoots fuel into the combustion chamber. It's got to mix it at just absolutely precise measures to make sure that there aren't heat surges, that there aren't problems with the nitrous oxide levels and so forth. Previously, this was manufactured, it took a long time to make, had 20 different pieces that all had to be welded together. Now it's being printed using 3D printing. It's one piece. There's no waste. It's 5 times quicker to make. It's faster to make. It's 5 times more durable than the existing nozzle. It is a pound lighter than the existing nozzle, and that means it saves about 40 pounds per plane. And when it comes to aviation, as many of you know, the lighter is the best. It's absolutely essential. So they're making this. Now, from a litigation standpoint, let's say something goes wrong. Well, we'll get to that in a second. Let's talk about automotive real quick. Automotive, this is becoming more and more used. Now, let's say this is not the perfect example, but let's say you're a collector of old cars, and you've got a 1938 Duesenberg. And fair disclosure, I'm not the biggest car guy, so I'm not even sure if Duesenberg made a 1938 model. Maybe some of you know. If they didn't, correct me afterwards. But let's say something, you dent that, and you need a replacement. Well, you can't go down to Napa Auto Parts and say, tell me all the different types of side panels you've got for the 1938 Duesenberg, because the answer is going to be 0. So what if you do if you're a collector? Well, if you're like this guy, who actually has about 200 old cars, Jay Leno, he actually has a 3D printing machine, and he prints replacement parts. People are printing engine blocks now out of 3D printing. It's not for commercial use yet, but it's coming. Finally, one of the things that automotive companies are now doing is printing full cars, obviously the outside of the car. We heard about the example at the auto shows where they're printing real ones that aren't roadworthy yet, but they're printing the outside, the shell of the car for wind tunnel testing, as opposed to the previous method where we all saw where they're shaving off clay in just right amounts and putting stuff on where they shaved off too much. Now they just program it, push a button, takes some time to print, but they can do it precisely. So we're seeing it in automotive. We're also seeing it in life sciences. Portions of skulls that people are using if they have to have brain surgery. One of the stories I heard about recently is somebody who was in the military who was hurt by a roadside bomb in Afghanistan, and who they had to remove a portion of his brain to relieve the swelling. Well, they had to get a replacement part, and in the past they used different plastics and so forth to put that on, but they didn't have a precise way of measuring. Now what they can do is with 3D printing, they can take a picture, they can send it to the United States. That can be printed out in a matter of hours, put on a plane, put on a military plane. 24 hours later, they're putting this precise piece of skull replacement in an operating room in Afghanistan on that person's head. We see it, we talked about the teeth before. So let's focus on how litigation is going to be changed by 3D printing. We are kind of in a brave new world. There are a lot more questions than there are answers, but let's take that GE jet engine nozzle, for example. Let's say, God forbid, a plane crashes, a 787 crashes, the NTSB does its investigation, and it turns out that that jet engine nozzle was to blame. Now let's say you're GE, or you are the component part maker who made that part for GE. Well, there's a good bet that you're going to get sued. How do you prevent that from happening in the first place, and how do you protect yourself if it does happen? Because it's not just you who's going to get sued if that part that was manufactured using 3D printing was made. It's going to be the software designer who designed the software that told the 3D printer how to lay down its material and build that material. It's going to be, we're going to have all sorts of questions. We're going to have the question, was there a defect with the jet engine nozzle, and where does that lie? Does it lie with the original design by that software engineer? Does it lie with the product that you made? Did the digital file somehow get corrupted? Was the 3D printer that it was manufactured on somehow defective? Was the material that you used? And for GE, they're using not plastic for that nozzle, but kind of a chromium, I forget what it's called, I think chromium chloride, a cobalt chromium metal to actually make that. So we're talking more, we're talking about food, we're talking about metal, we're talking about plastics, obviously. Was the material wrong? Was there a human error with the 3D printing manufacturer? These are all questions that are going to get asked because everybody, unfortunately, is going to get sued. The questions continue. Who's liable? Is it the software designer? Is it the manufacturer of the printer that's laying that down? Is it the manufacturer of the printing material? You bought that printing material from somebody and you said, we need cobalt chromium metal that meets a absolutely specific levels of tolerance and so forth. What if they gave you the wrong material? Was it you? Was it the end user? Was it the airline who failed to maintain it? Where do we look? Well, we look to the software designer first. And incidentally, if they're sending you software on any of those, you need to get a new software designer. Particularly that big black one. You don't want it on a floppy disk like that. You're going to look at the materials maker. You're going to look at the 3D machine manufacturer, you're going to be looking at yourself. If you are a component part maker, you're going to be looking upstream to whoever you gave it to. If you are making that for GE, did they somehow install it incorrectly? Did they somehow tweak it that caused problems? Or the end user, the airline. So let's talk about software very quickly. Is the software traceable? Because with 3D printing, as we heard just a moment ago from Alan, there's some people who said, you know what, we're going to put our software out there. Anybody who wants to make this part that we're already making, we'll put it out there. We'll put it on the Creative Commons. Or you might hire somebody to specifically do that design for you, a software company. Or you might have that in-house, some of your software folks. So where are you getting your software from? Are you getting it, again, from the Creative Commons? What could go wrong with the software? Well, if anybody here has a computer, and I'm guessing everybody does, or any kind of device, things go wrong with software. The software could be designed for a different purpose or a slightly different product, but you try and use it. Maybe you try and use stuff that's made for a slightly different design, but you try and tweak it, but your tweak doesn't work. You have corrupted software. Sometimes when you open up a CAD file on a certain system, it's going to corrupt it. You might not realize it first, but once the product is made, that product might not exactly work. So who is to blame for the software problems? Well, if you're the manufacturer and you've hired some software company to do your software design for your 3D printing machine, hopefully the answer is not you. Hopefully it's the designer, because if you're getting sued, you don't want it to be you. Who's on the hook for the software problem? Again, hopefully anybody but you. So how do you do this? How do you make sure that if you decide to go into 3D printing and you are going to hire an outside company to do the software coding for you, how do you protect yourself? You protect yourself by negotiating hard-hitting, specific contracts with that software designer that state exactly what they are building, how it is going to work, the tolerances of this item that you are building for. You want to put as much detail as possible in there to protect yourself. And the same thing goes for materials. If you are using materials, whether it's plastic pellets or powdered metal or some kind of food item, people are now printing replacement parts, replacement wheels for lawnmowers. Sounds kind of far-fetched, but actually people are now printing whole 3D printed lawnmowers. Now let me go back for 1 second. Let's say you are hired to print those wheels using 3D printers. And you have a choice of materials to make it from. And one is a kind of plastic called polyethylene, which is biodegradable. Polylactic acid, which is biodegradable. Or you could use high-density polyethylene, which is not biodegradable. Well, anybody who's mowed a lawn in the morning knows that there's dew and there's water, and that part is going to get wet. So if you choose a biodegradable material, very good chance that over time that's going to fail. So you need to know what materials you need to use, and more specifically, you need to know what do I know about the materials? Do I even know what's in the 3D printed materials? Do I know that it's right for my product? If it needs to be biodegradable, well then it better be biodegradable. If it can't be biodegradable, it better not be. Is the material manufacturer providing me with MSDSs? So if something goes wrong at the plant, I know what to do. What is the risk of not knowing what's in the materials create? It creates a lot. Because it means if a product fails and it's the fault of the material that you decided to use, well, who's going to be on the hook? It's going to be you. So you want to know what's in it, and you're going to have to ask, just because I made a 3D printed prototype out of one material, well, does that mean it's going to work on the finished product? Maybe not. Maybe if I'm making it out of a different material, for example, that if I am using that non-biodegradable the material for the first product, and then I choose to make the final end user products out of biodegradable materials, I'm going to have a problem. So you need to be thinking about all these questions ahead of time. Then you have to ask, is this material certified for the use that we're using? Certain states and the federal government, and we're going to be hearing about this, say you can't use certain materials for certain purposes. Is it safe to handle? Are you putting your workers at risk? If there are issues, You need to provide them with, whether it's face masks or gloves or what have you. Is your product going to be coming into contact with the human body, like that skull piece, or food? Is it going to be a tray that people put food on? Well, if it is, you need, again, to be asking the question, is the material that I'm printing with safe to come into contact with food? Does it leach things out? If there are colorants, have those been tested for safety? All of these questions, if you think about these and answer them ahead of time and think about the problems they can create, you can reduce your risk of something going wrong with your product and reduce the risk of having to come see me, which you don't want to do. Who's on the hook if there is a problem with your materials? Again, hopefully anybody but you. How do you make that happen? Again, hard-hitting, specific contracts with your materials provider that says exactly what they're providing you, that the tolerances that it's going to meet are going to be there with the shippers. If something shouldn't be shipped above a certain temperature, and it is, and then that causes a problem with the material, you want to be protected. You want to be protected with a contract. We're in a brave new world. There are few regulations when it comes to 3D printing. There are lots of questions as we see. There are few answers, but you want to be thinking about these questions ahead of time. So you can, number one, avoid litigation, if at all possible, and number two, if litigation occurs, you want to be protected with those contracts that provide you with indemnity from the software designer, the material manufacturer. There's not a whole lot of cases out here. What do? Again, contracts. Protect yourself with a contract up front with the software designer, with the materials providers, with the 3D printing manufacturer, possibly with end users to make sure that they're using it right and they can't point the finger back to you, because ultimately litigation, if you've gone through it, is kind of like musical chairs. You want to have a seat when the music stops, and you want to make sure that you are the one with the seat. And if something else goes wrong, it's somebody else who's on the hook for it. Again, if you think about these problems ahead of time, hopefully nothing will go wrong. Let me talk very quickly about some insurance issues. The first thing that you want to do if you haven't entered into 3D printing and you're thinking about it is have a talk with your insurer or your insurance broker, because you want to make sure that you tell them about these new issues. You're going to have new machinery at your plant. It could create new risks. It could also lessen the possibility of risks, which might reduce your insurance premiums. And obviously that's a good thing. So you want to talk about with your insurance broker, do I have coverage for various occurrences? For example, we talked about intellectual property claims. Well, if you're using somebody else's software and then they all of a sudden say, no, you tweaked it, you weren't allowed to tweak it, do I have coverage for that? If I have coverage, is it going to cover me with new machinery, like 3D printing machinery? You want to ask, do I, if I start to use this new machinery, have protection if there are products liability or wrongful death claims? You want to make sure that you do. This is something that you want to think about ahead of time. You'll be able to sleep a lot better at night. Do I have business interruption coverage that is going to protect me with this new machinery? If I'm using a very high-end 3D printing machine that costs $100,000 or $200,000 to buy, and something goes wrong and the 3D printing machinery company says, yeah, it's going to take us a couple of weeks to get your replacement part, but you've got a customer who needs a part in 2 weeks, not 2 weeks, but in 2 hours, and they say, we're going to have to shut down our production line, we're going to sue you. Well, do you have coverage? Again, that's something that you want to talk about beforehand. If you're using software, particularly if you're designing the software, you want to know if you have technical professional indemnity coverage. Do you have coverage for recalls? If now with this new technology you're going to be able to sell things beyond the borders of the United States and that's something that you're not doing, again, you want to know if you have coverage. Are there potential risks, increased risks of fire? Some of these machines, as we heard, tend to run hot, several hundred degrees. Now, that might be less hot than some of the equipment you're already using, but again, you want to know this ahead of time. You should be also thinking about the following, because these are the kinds of things that could help actually reduce your premiums. Are there increased risks of manufacturing risks when using 3D printing? Maybe you could argue that they're not, because these are more precise machines than what you're using now. Are they safer to use? Are there fewer chances of people getting injured using these machines versus some huge press that has thousands of pounds of PSI using it? Probably. again, if you can point to your insurer that you have very good knowledge of where your software is coming from, and you've got knowledge of where the printing materials and the printer is coming from, and you've got these contract protections, you can say to them, hey, we've got things covered. We have reduced our risk, which means we have reduced your risk, Mr. Insurer, which means you should reduce our premiums. Ultimately, when it comes to litigation and insurance, you want to keep calm, document everything, get very tightly worded contracts with the people you're working with, because ultimately it will help avoid litigation in the first place, and if it does occur, it will protect you in the second place. I'm happy to answer any questions, but I know we're running a little long, so I want to move to the next part, and all of us are happy to stick around afterwards and answer any questions you might have. Thanks.